explain it. This is, have you ever seen one of these before? Okay, how do you use them? What you do is you pick your time. This is 5, 3 a.m., 6 p.m. You pick the time, so say you go out at 7 p.m. on September 15th, you put it at 7 p.m. Or if you go out in July, you turn it to 7 p.m. July 10th. And then this will show you everything that's up in the sky that night. And to use this, the north, west, they're marked here. So if you're looking to the west, say you watch the sunset, you know where the sun's behind you. North is to the right and left. And so if you turn to the north, then you would if you turn to the north, you put this to your feet. So whichever way you're touring, you put that to your feet. This is
Yes. You want to take this home? You can roll it up. Put a little rubber band. In order to understand where comets are in our solar system, you have to understand the solar system. So let's talk about the solar system first. All right? What is the first thing, and I'm talking to mostly to people under 18. What is the biggest thing in our solar system? Sitting right in the middle. You know. She's an Astro member. That's so don't notice she's got a name tag. What is the biggest thing in our solar system?
The sun.
The sun. There we go. You want to be the sun? All right, here you go. Why don't you stand over here on the side? We're going to line you all up in order. All right, now, before we get to the next thing here, I got to ask Katie a question. Katie, did your very elegant mother make you something today?
Yes, she did.
What did she make you?
9 pickles.
9 pickles?
Uh-huh.
So say the whole thing. 9.
My very elegant mother
just served us
yeah,
9 pickles.
Yeah.
Does anybody know about that? Yes. Now you can.
Yay, I do know all about it.
You know about the 9 pickles? Go ahead, tell us.
Stands for Mercury, Venus, Earth, Mars, and so on.
Now, how is she remembering? All right, the sentence, guys, remember this, and kids, you say it with me. My very elegant mother just served us 9 pickles. All right, that's called a mnemonic device. What that is, the first letter of each word starts with the first letter of a planet in order from the sun. So that's how you remember it, okay? So the first one, mine. What's a planet that starts with an M? Yes?
Mercury.
Mercury. All right, how many kids we got? All right, we're going to have to do 2 apiece at least. All right. You want to hold Mercury also? All right, hold the sun in your left hand, and here's Mercury. Now, Mercury is the closest planet to the sun. Hold it up so everybody can see Mercury, all right? And it's just a big gray rock, basically, and it's got a bunch of craters on it, all right? Small craters. Now, my very V, what's a planet that starts with a V? This guy here, you know. V. Venus, very good. You want to be Venus? There you go. All right, now Venus, hold it up so everybody can see. All right, get next to him. Hold it in your left hand. Your other left hand. There you go. All right, now Venus is actually a very cloudy planet. They've taken pictures of it with X-rays and ultra or whatever pictures through the clouds, but there's pretty much a pink and reddish kind of a cloud base. Now, first thing we're going to do, this is dry ice. What is dry ice? Anybody know? Anybody except Aaron know? What is it? No. Carbon dioxide. How did you figure that out? Now, it's frozen carbon dioxide, and carbon dioxide is a gas. That's why, if that was still working, we'll throw another one in there. Well, we're going to smash some of this up. All right, let's see. There we go. All right, we're going to trace. All right. Yeah, try not to touch it. This stuff, don't touch it with your hand. Why shouldn't you touch this with your hand? Why? Go ahead, Aaron.
Your hand will freeze.
Your hand will freeze. It's so cold that it actually burns to touch it. All right. Let's get some of it in here now. See how it's going. All right. Dump some of it out. There we go. Whoa! That looks pretty good. Look at that. See that? That's how you know it's gas, because when it melts, it gives off gas, or steam, not water. All right, where's the spoon? Here we go. You want to mix? Here, put the gloves on, Erin. No, Erin's going to help. I promised Erin 6 months ago that she could help.
She's holding you to it.
There you go. Give it a mix there, Erin.
Josh.
Does it take her this long at home to put gloves on?
Yeah, it really does.
All right, mix it up. Good, that's enough. All right, now. We have carbon dioxide, frozen gas. Next thing we need is this stuff. Anybody know what this is? Anybody except Erin know what this is? Yes. H2O, very good. You know where we get this? From the tap, you turn it on.
I think that you can breathe it.
All right, let's pour some of this in here. I don't know how much to put, so we'll put that much. Whenever you don't know how much to put a lot. No, put a little.
You need to wipe your face and your eyes.
All right, now that we put that in, and there's so much steam, I can't see what we're doing anymore. All right, we need more water, I think. All right, here we go.
It's great for Halloween.
You can call me,
Dry ice?
you could call
Dry
me.
ice and water and it gives you all...
All right, here we go. Now, that looks like, what's that look like? All right,
Dry ice and water.
dry ice and water. It was like I said, everybody for the last week was discussing, what is Kate going to wear at the royal wedding? I was the only, why am I the only one that knew? A wedding dress. And I was right. Did you see it? It was a wedding dress, right? All right, now, there is a rumor among scientists that possibly life did not arise on Earth all by itself. That life may have been deposited here, or the building blocks of life, some of them, or even all of them, may have been deposited here by comets, all right? So, that's why we're going to add organic material, or diluted Pepsi, and corn syrup to the comet mixture here. There we go. Pour some of that in.
So if somebody calls me an alien, there's some truth to it?
What?
If someone calls me an alien, there's some truth to it?
In your case, Morrow, absolutely. Now, let's mix that up. Here, Kate, here. Erin, you want to come and give this a mix if you can? Just kind of pick it up and, all right. See, we might need some more water, I don't know. Good job. Try to keep it in the bowl.
Just like at home.
Yeah, I think we need a little more water maybe. Well, the water's freezing. I think I'm supposed to be doing this faster. All right, now the next thing, comets. You don't want to get too close to a comet. Why? Because they have these little squirt guns in the, no. Because they smell. They're full of ammonia, all right? So what we have here is a little bottle of ammonia for windows. There you go. All right, so we're going to put some ammonia in there. Maybe you'll get a nice yucky smell there. All right, let me see how it looks. All right, looks like we're doing good here.
Yeah. Now, typically galaxies that we view, some galaxies, because they're such large galaxies, they're not viewable. Even though they're large galaxies, they're not very bright. And with the telescope, you're limited to how far you can see by how bright the object is. And then you're dealing with sky conditions and all that. So an object you may be able to see one night, you come out and you go, oh, there's some wispy clouds, and it's just enough to block out that little bit of light where all of a sudden you looked at it last night, why can't I see it? It's just enough ambient light, could be city lights, or just enough haze in the sky that you're not unable to see it the following night. What that is they still have a very solid mirror in the back of telescopes that collects the light, but the secondary mirrors, what they can do is they can actually sense and detect. They use lasers to detect the atmosphere. And as the atmosphere changes, and you ever see, wonder why stars twinkle? That's the light coming through the atmosphere getting bent and twisted. They have onboard computers on the telescopes that use a deformable secondary mirror, and what it does is it shoots a laser that detects the atmosphere and instantaneously changes the front mirror to counteract the bending of the light coming from your eye. Can't pick it up. It's beyond the limits of your eye. That's why you need a telescope. But even though you can't see it directly, you would move to the star near it and hopefully get close enough that it's in the field of view and you'd move to that object and then he can observe. This one, luckily, this one's got an internal database in the computer, and you turn the power on, the scope orientates itself, you do what's called an alignment, and what it does is it'll point itself in the direction of a star, then it'll ask you to manually, with the control pad, bring that star into the center, then you'd hit OK. It would, what it does is typically does a 2-star alignment. It would go towards the direction of the second star. It would get relatively close to that star again. You would move it manually with the keypad, get to that second alignment star, hit OK. Now, this has a GPS signal on it, but you're also, without the GPS, you would just need the telescope to know what time of day it is and where it is located on Earth. And with that information, and with alignment of the 2 stars, it's able to triangulate where its position is on Earth, what time and date, what season, and it will know all the objects in the sky. So if I wanted to tonight, once this is aligned and ready to go, I just go in the keypad and I go down here to planets and I hit Saturn, I hit enter and go to, and the scope will automatically move, point at Saturn, and track it for the entire night. Now Saturn's going to typically be up in this area of the sky, and you never burnt bugs and things or anything with a magnifying glass, have you?
Leaves.
Leaves? You burnt leaves with a magnifying glass? All right. Well, you know how that light is, okay? Imagine that being right in your eye. Blind.
Yeah, the one guy that was standing here said he saw it. And you know what's funny? The last time we were here, the college. Yeah.